Let's talk about summations in calculus. So we're going to talk about summations. What we're going to do is we are going to add a whole bunch of numbers together. First of all, if we use a capital sigma, that stands for summation in most math. So that is sigma, it's a capital sigma. And down here, we're going to put something like this, k equals 1, and then up here we're going to put n. Now, k equals 1 to n is how that is written. And what happens is this is considered a counter. So we are going to go 1, 2, 3, 4, 5, 6 until we get to n. That's what the summation is. So let me give you an example. If I've got a sum, k equals 1 to 6 of 4n, then what that's going to do is it's going to be, first of all, 4 times 1, because n is 1. I should have said k, excuse me, k is 1. So k is 1 plus 4 times 2 plus 4 times 3 plus 4 times 4 plus 4 times 5 plus 4 times 6. Now we could add that up, but that's just kind of a super addition problem. It would be like a multiplication problem. That's sort of a super addition problem, but that's how we read this. So we start here, end here. We go by the counting numbers, the natural numbers, from 1 to 6, and let them equal. Now there are all kinds of summation formulas, and the first one that we're going to talk about is this one. So let's talk about some formulas, some that will be useful when you start to find area under curves. All right? First formula is this one. If I've got k equals 1 to n, notice I'm starting at 1, and like right here I have a constant, like 4 or 6 or something like that. I'm going to say it's a constant c, all right? Then the answer to this is c times n. So that's probably pretty reasonable. You could test that out. The second one we're going to deal with is this. If we've got k equals 1 to n, and we've got the actual k value, what happens there? Well, there's a really cool way that you can do this if you want to, and what you would do is you could start writing it out, all right? So I'm going to do that. I'm going to say, oh, okay, well, this is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and so forth, all the way until I get to plus n. Now I'm going to do this again. This probably looks kind of ridiculous, but I'm going to add another summation. So k equals 1 to n, but I'm going to write it backwards. I'm going to write 1 plus 2 plus 3 plus and so forth all the way down to, here I'm going to have, I've got k here, n minus 1. The one before that was n minus 2, n minus 3, and so forth. So I've got two sets of this, two additions of this. So I've got two sums, making this look like algebra. K equals 1 to n of k, and that is equal to 1 plus n. 2 plus n minus 1 is 1 plus n. 3 plus n minus 2 is 1 plus n. Notice how this goes. Got a whole bunch of these. So I've got 1 plus n. Now how many of them do I have? Well, if I count from 1 to n, I have n of them. So this is equal to n times n plus 1. And this is 2 times k equals 1 to n of k. So if I divide both sides by 2, I get this. I get the sum of k equals 1 to n of k is equal to n times n plus 1 over 2. So there's a formula for you. Now, there are a number of different formulas, and I'm not going to show you all of them in terms of all the details of this, but let's take a look at the one for k squared. If we've got k equals 1 to n of k squared, then it's equal to, this is kind of interesting, it's n plus 1, 2n plus 1 over 6. And then if we have k equals 1 to n of k cubed, that one's equal to n plus 1 over 2 all squared. Most books don't write it this way. They usually write it as n squared, n plus 1 squared over 4, but I like to remember it this way because it's just like this one, only squared. The numbers are not really all that closely related in a sense, but they really do work out that way. So let's take an example and find the value. And then we can kind of do it the long way too. But let's take a formula. Let's add k equals 1 to, let's say, 3, just to keep this kind of easy. And let's have this. Let's have 5 plus k squared. Okay? Now I'm not using k cubed, not that it's not important, I just am not using it. So let's separate this out. The one with 5, that's just a constant, so we come up here and go, okay, constant is 5, so, and the n value is 3. So the first one is 5 times 3. Then the k value, that's this one, right here. The k value goes with this one, it's n plus 1 over 2. Well, n is 3, so I'm going to put 3 plus 1 over 2. Then the third one is k squared, so I'm going to add it. That one's this one. K squared's formula is right here. The n value, remember, is 3, so that one is 3. 3 plus 1 is 4, and 2 times 3 is 6, plus 1 is 7 over 6. So let's figure out the value of this. 5 times 3 is 15. Now this one, this is 3 times 4 over 2. Well, 4 over 2 is just 2, so 6 is the value there. So I've got 5 times 3 is 15. I've got 3 times 2, and that one is 6. And then here I've got plus. Now I've got 3 times 4, that's 12 over 6, so there's 2. So 2 times 7 is 14. So I've got 20 plus 15 is 35. Now let's try this the long way, okay? So if I put 1 in here, I've got 5 plus 1 squared. So 5 plus 2 is 7. If I put 2 in here, I've got 5 plus 2 is 7, plus 2 squared is 11. And if I put 3 in here, I've got 5 plus 3 is 8, plus 3 squared is 9, so 8 plus 9 is 17. This is 18 plus 17 is 35. So 35 here, 35 here. Now, in a way, this one's easier at this point, but that's because I only went to 3. What if I would have gone to 35 or 300? This one would have been just as easy with 300. This one would have been very difficult. So that's how you can use summations, and it's going to be used in calculus. You haven't seen any derivatives in this particular video, but they have a lot of relatives to this. We also will use some other things, so we're going to use them to find area.